With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. Two uniform spheres made up of same material, radii are r and 2r. Mass of the smaller planet is m. They start moving from rest toward each other from a large distance under mutual gravitational force. The collision between the stars is inelastic and the coefficient of restitution is half. The maximum separation between their center after their collision. So we know that if I talk about the kinetic energy before the collision and kinetic energy after the collision, let's say they collide with some kinetic energy, and if you see they are made up of same material, radiuses are like r and 2r, right? So if the material is same, then you can see the mass is rho times of volume, and we know that the volume is rho pi 4 pi by 3 r cube, so it is proportional to basically r cube. So if the r became 3 times, right, then the mass will become 8 times. So if this is m, this is 8m. So before the collision, let's say the kinetic energy was k naught. After the collision, it will become k final will be initial by e square. Here initial into e square. Here e square is given, it is half. So it will be half square is 1 by 4 times of initial kinetic energy. So if you see here, right, initially they was at infinity, and after that they collide, right? And during the collision, the distance between their center will be r plus 2r, that will be 3r. So if I talk about initially, the potential energy and kinetic energy was 0 because they started from infinity and from rest as well. They start from rest from a large distance. So at large distance, the kinetic energy will be 0 and potential energy will be 0 final. So from infinity, when they collide, right, what will be the kinetic energy? So we already have seen that during the collision they have a kinetic energy of k naught. So I will write initially all the kinetic and potential was 0, and this is k naught, and the potential energy was this. From here you will get the kinetic energy of the collision, right? Kinetic energy of the collision is simply and after colliding, they move away from each other, right? If they move away from each other after the collision, the kinetic energy after the collision, we already have seen it is k naught by e square, that is k naught by 4, and it is 2 by. Now you can apply the mechanical energy conservation from after the collision kinetic energy to final potential energy when they will stop. So now they start from this position with some kinetic energy, and the maximum distance between their center is smaller. So I will write here initial kinetic energy is this. And initial potential energy is this. Finally, the maximum distance between them, let's say it is r. You can cancel out this. So 2 by 3 minus 8 by 3, it will be 6 by 3. It is 8. Now you can get this small r, it is equals to 4r, and this is the answer of this question. The maximum separation between the center will be 4r. Simple. Now you can check for the option. A is the correct option. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.